Hello everyone. In this episode I'm going to talk about common value environments. The thing is, I will not provide any formal theory for common value auctions. The reason is that the auctions and the optimal bidding strategies are much more complicated, and so we usually talk about common value auctions in more advanced courses. But the thing is, I would like to give you some idea about what the common value auctions are, or the sort of the environments are, and a kind of a very well-known concept which is called as winner's curse occur. All right, well, first off, the common value auctions are the environments where all the bidders have a sort of a common value for the item. But the thing is, for example, let's say the bidders are going to be bidding in offshore oil lease. Okay, they're going to basically lease some territory, and they're going to extract oil from this region. While the amount of oil, or sort of the value of the oil, is same for everyone. I mean, it's not exactly the same, right? The costs may differ from the bidders to bidders. But the thing is, the market value of oil is the same. So in a sense, the value of the oil extracted from this field is, well, give or take, a constant across bidders. But the problem is nobody knows the true value. I mean, how much oil is there in this territory is an unknown. So what happens is usually, different bidders, different firms hires experts, and those experts basically sample and try to understand out of those samples how much oil in estimation, in expected terms, could be possible in this environment. Well, the thing is, obviously, those experts could have different abilities. Some experts could be super experts, some of them could be a lousy expert, and so their predictions could have a bigger error term. Or even though everybody hires a very well-known or sort of a sophisticated expert, well, the thing is, they are going to sample different parts of the entire region, right? They can't survive the entire region, so they're going to sample different regions. And so by chance, they may actually get different estimations. So the thing is, there's a common value, but the thing is, every bidder is receiving different signals, but the signals are correlated because nevertheless they are looking at the same picture. It's just the different parts of it. All right. So we don't have independent private values anymore. It's common value, but at the same time the signals are correlated. So if I know your signal, on top of my signal, I'm going to have more information, because that kind of means they're two expert opinion in a sense. All right. So, well, I am going to give you a very simple example just to explain you what we mean by winner's curse. Okay. So let's suppose, again, the oil lease example. The true value of the oil, if you win the object, if you win this lease, it's $100 million. Let's suppose this is the true value. Okay, but the thing is, as I said, the bidders are going to receive signals. And so the experts are going to make a prediction. So simplify it, the experts are going to either make accurate estimation or a slightly overestimated or slightly underestimated. Let's suppose, okay? So what does that mean? That means even though the true value is $100 million, it is likely that you are going to get an estimate $110 million. It is likely that you're going to get exactly $100 million estimate from the expert, or it is also likely that you may get $90 million estimate. And suppose it's equally likely, all right? One third, one third, one third. So basically, you may get $110 million estimate, $100 million estimate, and $90 million estimate. There's no way else you can get something else. Okay? Well, the thing is, you don't know the true value. All right? as a firm. So there are two firms, let's suppose, firm A and firm B. Firm A doesn't know the true value. It can be anything. It could be zero, it could be $5 million, $1 billion, okay? So the $100 million is just one of, a piece in the sandstorm. So let's suppose firm A gets a signal, and by the way, let's suppose there's no other bidders, okay? There's just two guys. So firm A, let's suppose, gets the signal 110. Remember, it was one of the signals. And the other guy gets the signal $90 million. Again, it's one of the signals. Don't forget, I'm sorry, those guys also know that the signal they're going to get is going to be in the neighborhood of $100 million. I mean, not $100 million, but it's going to be, so they know the signal structure. That's important. So whatever the true value is, V, which they don't know, we know, I mean, you and I know it's $100 million, but they don't know this true value, okay? It's V, let's suppose. Well, the thing is, they know that the signal is going to be either V itself, V plus 10, or V minus 10. That's all they know, okay? So that's very, very, very important. So what does that mean? So when firm A gets signal 110, A is going to deduce what? Well, if I get a signal 110, all right, well, that means the true value of this oil lease is no longer $200 million or no zero, right? Because I know that the signal is going to give me a rough estimate, but very close estimate of the true value. So therefore, A is going to deduce, right? It's going to update its belief in a sense that, well, the true value is either 120 or it's 110 or it's 100. Agree? Because, I mean, there's no way, once again, so if I receive 110, all right, and if this is, I mean, for example, if the true value is 90, okay, if true value is 90, there's no way I can receive 110 signal, but I received 110. So therefore, true value 90 and below is impossible. Well, what about true value 130 and above? By the way, let's suppose the numbers are multiples of 10 millions of dollars, okay, for simplicity. So 130 million and above, any signal, I mean, true value, I'm sorry. Well, this is impossible. If the true value was $130 million or more, the problem is I can't, there's no way I can receive a message 110. You see what I mean? So therefore, once again, it's like the true values are going to be one of those three. Once again, I assume that the possible values, true values, are multiples of 10 millions of dollars for simplicity. I just make things discrete. So this is 1/3 probability, 1/3 probability, 1/3 probability, right? And so if I bid my signal, all right, my B of S is equal to S, all right? So I received the signal 110, and so what is going to be my expected payoff? Well, it's going to be 0, right? How do I know that? Well, I mean, simple. With 1/3 probability, I'm going to get $120 million. With 1/3 probability, I'm going to get $110 million. With 1/3 probability, I'm going to get $100 million. Minus whatever it is, if I win, obviously, I'm sorry, I forgot to say this. If I win, I'm going to pay my bid, which is 110. And so this expectation minus 110 is equal to 0. So this is expected payoff if I win. If I lose, let's suppose this is the first price auction, okay? Highest bidder wins and pays his bid, okay? So in that case, my expected payoff is going to be 0. If I win, if I lose, it's going to be 0. So you know what? It seems like optimal for me to bid my expected, my signal. Same for the other guy in a sense. So question is it really an optimal strategy? I mean, like this, what the players do in the second price auction. So everybody bids his or her signal. It looks like optimal, right? But is it really optimal? Well, no, it is not. Why not? Well, because here, once you learn that you win the auction, you are actually going to update. So when you learn that you win the auction, you still do not know what's the true value, right? You will never learn the true value. In the private independent value auctions, you learn the true value before the auction begins, right? You just pull a signal, which is your valuation, and you know the valuation. So there's nothing to learn about it. But here, even though you make a bid and you win the auction, you still don't know how much worth of oil there is in the field. So you still have a belief about it. But the problem is, let me take it back. The problem is your estimation before the bidding and after winning is going to be different. How so? Well, so let's suppose firm A bids his signal and also firm B bids his signal. And everybody knows that. I mean, both firm 1 and firm 2 knows that everybody is going to bid his or her signal. All right, so the expert told me 110, I'm going to pay 110. If expert would have told me something else, I would pay that one as my bid. Say I know the second guy, the second firm B will also do the same thing. All right, so we bid, and then the auction is over. I learned that I win the auction. Okay? But the thing is, am I going to observe the bid of my opponent? Probably not. Depends. In some auctions, you learn it, sometimes you don't. But the thing is, if I learn that I win, so A wins, what does that mean? That means, remember, I bid $110 million, and so my opponent should have been bid less than $110 million. So he can't be bidding something higher than 110. He should be bidding something lower than 110. Remember, this is the first price auction. The highest bidder wins. I mean, almost in any auctions, highest bidder wins. So my opponent, firm B, bid something less than 110. Is it 100? Again, let's suppose that the bids are multiples of 10 millions of dollars, okay? So my opponent might have bid 100 or 90 or 80 or 60, whatever, but I don't know. The only thing I know, I learned, is that I bid more than what he bid, okay? So maybe he bid 100. B's bids, potentially, or maybe 90, maybe 80, I don't know. But the thing is, let's think of 100. So if it is 100, the best scenario, and I'll explain why it is the best scenario. If it is 100, well, I already received a signal 110. My opponent received a signal 100. Well, then, do I still think that the real value of the oil field is 120, 110, 100 with equal probabilities? There's no way. Because there's no way my opponent can receive signal 100 and I receive 110. And the true value is 120. Because remember, the signal is in the 10 plus 10 minus neighborhood of the true value. So if the true value was 120, the only signal my opponent would have got was 110 or 130 or 120, but no way 100. So that means 120 is off the picture. So I update my belief once I learn that I won the auction. Is it possible that it is 110? Well, depends. If my opponent's bid was 100, well, yes, this is a possibility. But what if my opponent's bid was 90? The problem is in some auctions I know it, in some auctions I don't. If it is 90, it's even worse, because if my opponent's bid is 90 and well, by the way, I know that he didn't bid 80, but if I learn 90, well, what am I gonna say? Hey, you know what? I received 110 as a signal. My opponent bid 90, and so therefore he received the signal 90. So that means there's only one possibility, is that the true value is therefore 100. If I learn that my opponent bid 90, okay? But as I said, whether I learn my opponent's bid or not, ignore that. Whenever I learn that I won the auction, it means my opponent bid either 100 or 90 or maybe less, but that means 120 is no longer a possibility. So what does that mean? That means the likelihood that the true value is gonna be changed and the values is gonna be changed, right? I mean, previously I was hoping and thinking that I'm going to pay $120. I'm going to receive $120 with 1/3 probability, 110 with 1/3 probability, 100 with 1/3 probability. So therefore, the expected estimation of the value was equal to my bid, because that was the zero expected payoff, remember. But now this is no longer the case. So what's going to happen? The expected estimation of the value is going to decrease. So that's going to decrease. But remember, my bid is still 110. So it is going to be less than 110. So that means my expected profit is my expected estimation minus my bid. So once I learned that I won the auction, this term, the expected payoff, which is this expected value minus my bid, which is expected value minus 110, this is going to be negative because it's decreasing. How much it is going to decrease depends on whether I observe my opponent's signal or not, or my opponent's bid or not. All right, so I don't want to specify it, but if I observe it, okay, like the simplest scenario, if I observe that my opponent actually bid 90, that means my expected valuation is going to be 100. All right, so if I learn I won, and if I learn that my opponent's bid was 90, well, then I'm going to learn that the true value was actually 100. And so my expected payoff, once the auction is over, is going to be 100 minus 110 because I paid 110. Remember, I paid my signal. And so my expected payoff is going to be minus 10. So problem is, a long story short, before players make a bid, if they bid their true signal, they hope that they're going to get a zero expected payoff. But once they learn that they won the auction, this new information is going to reduce their prediction about the real value, and so their expected revenue is going to be negative. So therefore, bidding your signal is not optimal. And this thing that I'm trying to explain you is what's called winner's curse. All right. So once you win, you don't actually get happy. Yoo-hoo! I won the auction. In fact, you're going to feel terrible because you realized that your estimation was way too optimistic, and so actually This is why you won the auction. So in order to, therefore, the optimal bidding strategy should eliminate the winner's curse. All right? And well, for this reason, the optimal bidding is harder to calculate in common value auctions. And the thing is, in order to prevent the winner's curse, the players must base their bids on their expected value, conditional on winning the auction. If you don't win the auction, you're not going to learn anything. But if you win the auction, you're going to learn something because everybody else's bid was lower. So that piece of information is going to change your perspective of the true value. But the thing is, the bidders are going to bid much less than their signals, even less than the first price auction. Auction formats are not going to be equivalent in the common value auctions. Open bid auctions, for example, they provide information, ascending, descending, Dutch auction, English auction. They provide information. As you see people are leaving the auction, you actually learn something, and so you're going to update your beliefs. So that actually eases the problem of winner's curse. And so the bids are going to be more aggressive, all right? Meaning it's going to be higher. However, in the sealed bid auctions, like first price, second price, all pay, no information will be revealed. And so the bids are going to be much more conservative because you kind of scared of sort of suffering the winner's curse. Okay, so that's it for this episode.